Okay, so we're looking at the standard triangles this time. We're continuing on with trigonometry. You've probably seen this, or you've definitely seen this before. This is just a refresher course, I guess. Now, probably the easiest of the standard triangles is this one. So that's a right angle triangle with 45-degree angles here and here. I'm just going to complicate the matter by instead putting my measurements in radians. Pi on 4, and that's also pi on 4. Now it's a standard triangle, so we're going to give it some standard measurements. That is 1 here and 1 here. So a length of 1 and a length of 1. Now if you did Pythagoras, you'd be able to quickly figure out that the hypotenuse is equal to the square root of 2. Now from this standard triangle, we can come up with 3 sine, cos, and tan ratios. We can come up with sine pi on 4 equals opposite over hypotenuse, which is 1 on root 2. We can come up with cos pi on 4, which equals adjacent over hypotenuse, which is 1 on root 2. And we can come up with tan pi on 4, which gives us 1 on 1, which is just 1. Now, if depending on who your teacher was, they may have also rewritten these two, not as 1 on root 2, but as root 2 on 2, root 2 on 2. You do that just by multiplying top and bottom both by root 2. This doesn't really change though. So our second standard triangle, draw this one a little bit bigger. Okay, so 90-degree angle again. This is the bigger angle, 60 degrees or pi on 3 in radians. And this is the smaller angle, pi on 6. Doesn't matter which way you write it around, obviously, but get in the habit of doing it one way every time. That way you don't get confused. Now, the order that I write these in is 1, 2, 3, but this is a root 3. Now just make sure that you get in your own habit for this triangle, drawing it in the same way every time. That way you won't make any mistakes when it comes to actually figuring out what's going on there. Okay, so from this we can come up with 6 different trig ratios. We can come up with sine pi on 3. That's going to be equal to opposite over hypotenuse, root 3 on 2. We can come up with cos pi on 3. That's going to come up with adjacent over hypotenuse, that's 1 on 2. And we can come up with tan pi on 3. That's opposite over adjacent, that's root 3 on 1, which is just root 3. Now, of course, we can do all of the pi on 6s as well. So sine pi on 6, opposite over hypotenuse, 1 on 2. Sine up. Cos pi on 6, which is equal to root 3 on 2. And tan pi on 6, which is equal to opposite over adjacent, 1 on root 3. Now, if you have trouble with your standard triangles, but you still want to know all of these values or still have a way to remember all of these values, what I would suggest is creating a table like this. Sine, cos, tan, and then pi on 6, pi on 4, pi on 3. That's 30 degrees. Oops, hang on. That's 30 degrees, 45 degrees, 60 degrees. Very, very simple way to remember it. Put 2's everywhere. 2, 2, 2, 2, 2, 2. Just in those top 6. Don't do the bottom 3 just yet. Now they're all your denominators. And now we're going to count 1, 2, 3, 1, 2, 3. And then you put square roots on the top of everything. Now, if you put a square root here, square root of 1 is just 1. So I'm going to put 1 there, but it doesn't mean anything. Put a square root here, so it's a square root of 2 on 2. Put a square root here, square root of 3 on 2. Put a square root here, but again, it won't mean anything. Put a square root here, and put a square root here. So that's our top 6. Now how you remember these next bits is up to you. I always put a 1 here. And then I look up here and I say, oh, there's a root 3 on the top there. Maybe I should put a root 3 on the bottom here. I know it sounds silly, but it works for me. And then finally, this last one, root 3. So that's how I draw my table, so I can have a nice little thing. This is particularly handy at the start of an exam, or if you're comfortable with your standard triangles, just draw in your standard triangles and use them. So this has been a revision video. There's nothing particularly, there's no standalone usefulness to this, but you absolutely need it if you're going to be able to do anything when it comes to the unit circle and trigonometry.